Good morning, good afternoon, and good evening, everyone. So today we're going to be doing part two of my exam slash midterm review. So here we're going to be diving into, I guess, equations of lines and planes for the most part. Uh, so yeah, okay. So let's start with our first one. I'm going to take a quick screenshot. So basically, the first one is finding the precise name for this function, for this surface equation. Okay. So how in the world do we do that? So if we're given 2x squared minus y squared plus z equals 4, how do we find what's the surface name of this thing? Well, we look at the variables, right? And we say something about them. We say something about their traces. So here we basically identify traces. That's what we have to do. So the idea is if we take out one of the variables, what would the equation look like? If we make one of them to 0, what would the other look like in the 3D space, right? So let's say we take out the x. If we take out the x, then we're in the yz plane. So in the yz plane, what's that going to be? Well, if we look at it carefully, we have this thing, negative y squared z equals 4. And um, we can actually see this is a parabola because of the y squared. So this is a parabola, right? So there's only two things or three things that we have to look at. It's either an ellipse when we're looking at traces. So when looking at traces, check if it's an ellipse or circle. That's one. Parabola, which we just saw, or hyperbola. How do we know if it's an ellipse or circle? Well, if let's say x squared plus y squared, if we see that, then that's definitely a circle. If it's something like x squared over 5 plus y squared over 2, that's definitely an ellipse because their numerical coefficients are different. But here, their numerical coefficients are the same. These are both 1. And lastly, no, not lastly, it's a parabola when we see something like y equals x squared. So that's a parabola. And it's a hyperbola when we see something like x squared minus y squared. So it's a subtraction. So it really boils down to three things here. Okay, so we found that. Now let's look at when we take out our y. So now the trace is going to be in the xz plane. And so what in the world does this look like? Well, we have 2x squared plus z equals 4. Oh, it's a parabola again. Okay, and if we take out the z, oh, it's a subtraction, and it's 2. So it's a hyperbola in the xy plane. And so, yeah. So what is the name of this thing? Well, if we were to draw a 3D thing, it's not super accurate. So I'm not gonna make it too accurate. But we have a parabola in the YZ plane. Um, okay, let's see. X, Y. We have a parabola at the YZ plane. So I don't know. As a parabola. I'm not gonna draw it exactly the way it wants to be drawn. XZ plane is also a parabola. And then here it's a hyperparabola in the XY plane. Actually, no, I think it needs to be exact, right? So I don't know. It would probably look something like this. And then maybe another one is like, I don't know, like this. And then another one would be something like, I don't know, like this, right? And then we get, I don't know, something like this. Okay, this is why I don't like drawing these things, because they really, when I draw them, it really doesn't help me at all. But yeah, it's just looking like potato chip here. And so this is what we call a hyperbolic paraboloid, which I hope I got that correctly. If not, I have to check my notes. But I should have gotten it. Yeah, a hyperbolic paraboloid. Okay, so that's that. Next thing we want to do, or the next question is we want to find parametric equations for the line of intersection of two planes. So really, when we're looking at lines of intersection or curves of intersection, really what we want are parametric equations, because that's what's going to help us determine that, right? So here, we're given two planes, and we just have to find the line of intersection. So we're given 2x plus y plus z equals 3. That's a z. And we're also given 3x plus y minus z equals 7. Now, how do we parameterize x, y, and z? That's the tricky part. Let me think. Well, maybe I could cancel these, you know? I could subtract the two things and then get something in terms of the other. I could do that. Or maybe an easier way. Well, actually, an easier way is not, yeah, an easier way would be to like, okay, let's look at the characteristics maybe. So what does a plane need? It needs a normal vector and a point, right? So when we're given a plane, we need a normal vector and some point. All of these have normal vectors, right? So if we were to draw a quick diagram, let's say that's one plane, the other one is this plane, I don't know. And their line of intersection is this thing. And both of these have normal vectors. What can we say? Well, their normal vectors are both perpendicular to this line, right? Both normal vectors are perpendicular to this line. And so what does that mean? Well, we need to find a direction vector of this line. Yeah, we need to do that. But how do we do that? Well, we can get their cross product, right? So one thing we learned, if we have this a vector here, another vector here, goes to 90. Well, we know this one, right? That's the purple one. And we also know their dot product is 0. But here we're given two vectors. So how do we go about it, right? Let me think. Um, well, if they're perpendicular to that vector, then if we get the cross product, right? So maybe if this was P1, this was P2, planes 1 and 2. This was not P. This was normal vector N1 and N2. Well, we can say that the normal vectors of these two, if we somehow get their cross product, well, we will get a vector that's perpendicular to both of these, which is that direction vector that we need, maybe a V, right? And so that's what we need. We need that direction vector in order to find our parametric equations. Okay, so that's what we're trying to do. We need to find a normal vector and a point for a line, right? So our first step is to find a normal vector, not normal vector, a direction vector that's actually parallel. Okay, so how do we get our N1 and N2? So maybe what we can do here is, oh, we see that plane 1 is my first thing here. And so we say my N1, or my vector here, is basically 2, 1, 1, right? Because it's the numerical coefficients of these. Okay, now I look at my P2. My P2 has 3x plus y minus z equals 7. So my N2 has components 3, 1, negative 1. And now if I get the cross product of this, then I'm supposed to get B, right? So N1 times N2, I, J, K, 2, 1, 1, 3, 1, negative 1. And I take out my I, so I get negative 1 minus 1 for my I, subtract. Take out my J, negative 2 minus 3, that's my J, add. And I take out my K, I get 2 minus 3 for my K. And I get negative 2I minus negative 5, so plus 5J minus K. So I have this vector here, this direction vector. And I'm done. I got my vector parallel. Now I need to find a point. Now, honestly, any of these could work, right? Like I could make this into any point because they have to be in both plane 1 and plane 2. So that's the only issue. Well, we could say one of them is 0, that way our lives are easier. So now we need to find a point. Maybe we can say z is 0, right? And so we have 2x plus y equals 3. We have this system. And my other one is 3x plus y equals 7. And then from there, I just compute. So I say, okay, this is y equals, or honestly, I could subtract these two. Let me do that because that's quicker. Let me actually do that. So I have 3x plus y equals 7. I subtract it to this one equals 3. I get x equals 4, right? Then from there, I plug in my 4. I get a y value. Or let me see if this works. This is 12 plus 4. Oh, it does work. Because I get 8 here minus 5. I get 12 here minus 5. So my x is 4. Yeah. And so my y is equal to -5. And so my point could be 4, -5, 0. Then from there, I have it. I have my parametric equation. So my x is 4. And then I add it to my direction vector. Oh, it's negative. So 4 minus 2t. My y is -5 plus 5t. And my z is 0 minus t. So it's just -t. And then that's it. I hope I got that one. Yeah, so I did. Yeah, so I got this. Okay, funny enough, I got the same thing. And yeah, 4 minus 2t, -5 plus 5t, -t. So that's cool. Got it. Nice. Okay, next thing. Okay. Now we're being asked to find the equation of a plane. So now this one's a bit trickier. Right? Because here, well, we're being scammed. No, I'm kidding. We're we want to find the equation of this plane. And it has to pass through. Oh, again, that's fun. Okay, if I do this, no, I can't. That's fun. There we go. Lucky. If I wasn't gonna access my pen again. So we want to find the equation of the plane. It passes through this point, and it contains this line. And then I want to find the y-intercept of that plane. So where it intersects the y-axis. Okay, so to find the equation of the plane, what do I need? I need a point, and I need a, what do I need? I need a normal vector, right? So let's do that. We actually have our point already, which is this. Now we just need to find a normal vector. So I want to find a normal vector. Now, how will I be able to do that? Well, it says here that this point contains this line. So this is a line. And what can I say about this line? Well, I can say a line has an initial point, right? And it also has a vector. So if I were to draw this out, I have this plane that I want to find. I have a line that I don't know. I need a normal vector that's perpendicular. I have a point somewhere. I don't know where in the world that point is. I'm assuming it's not here. Yeah, it's not, because 3, here it doesn't start at 3, it starts at 5. So that's definitely not it, right? So there's another point, P. We need another point, Q. So here we can say, okay, maybe another point in the line is Q, right? So let's extract what we can extract. So 5t, y is 2 or -1 plus 2t. I'm just trying to format it in a way that makes sense to me. So here we can see the point that was used here. So point on line. Let's call it Q. Let's say this is Q on line. Here we say this is 5, -1, 0. Right? That's the point here. There's another point. And now, what else can I do? I can find a direction vector here, right? So I need two things. I need that vector here, and I need a vector going here. So that I can find this normal vector that's parallel, because I'm just going to do a cross product anyway. So, okay, let's find we have that point. We have this point. Now I need to find two vectors. So I need two vectors here. I need a v1 and a v2. So find two vectors. So v1 is basically from Q to P. So from Q to P, well, it's just the difference in their components. So 3 minus 5, that's -2. 4 minus, let me just, Q to P. So 3, no. Oh yeah, 3 minus 5 is -2. 4 minus -1 is 4 plus 1 is 5. 1 minus 0 is 1. So that's that first vector. Now I need the other vector. Well, I already have that here. So this is these guys over here. So this is 1, 2, -2. Great, I have these two. Now how do I get the normal vector here? Well, I just get their cross product. So let's say I have that normal vector n. So now I can find the normal vector here. So here I say, oh, we have n, which is v1 and v2. Get the cross product of that. Then we get -2, 5, 1, 1, 2, -2. Then I get, I take out my I, -10 minus 2, that's I, subtracted. I take out my j, I get 4 minus 1, that's my j. And my k, I take out my k, I get -4 minus 5. And that's my k. Then I continue, I get -12, right? -12i minus 3j plus, or minus here, minus 9k. So here I get -12, -3, -9. Cool. Okay, now what do I do with that? Well, now I want to use that to find the equation of plane, or plane equation. So here now we just find the plane equation. So this is just as simple as wait a minute. Wait, for a plane I need, oh yeah. So I need my vector. Oh yeah, I need my normal vector. Uh, and I need my initial point. Oh crap. So it's gonna be x. I multiply it with, I hope I got this. If not, I need this in my cheat sheet. Yeah, I need this in my cheat sheet. I totally forgot what the plane equation is. Oh, so to get the plane equation, oh crap, I can't see anything. So to get the plane equation, okay, a, b, and c, x minus x naught, y minus y naught. Okay, yeah, I totally got it reversed. So that's the formula for that. The one that I need exactly. So given some, basically the formula is, so here's my tip. Given some normal vector which has a, b, and c, and initial point b naught, x naught, y naught, z naught, and arbitrary point x, y, z. Equation of plane is just a, x minus x naught plus b, y minus y naught plus c minus z naught. That's equal to 0. So I'm just going to apply that. So I have negative 12 x minus my initial point. So x minus 3 minus 3 y minus 4 minus 9. And then this is z minus 1. Okay, what's funny is I could make them all into positive. So I'm just going to do that. Plus 3 plus 9. I probably solved it a different way. I'm not super sure. I totally forgot how I did. Okay, so I did get the exact same thing. But how did I do it before? Also, I found a normal vector n. I need to find a direction vector. And I need to find a point on the line in the plane. Oh, so I did actually a bit differently here. Yeah. Then I find another direction vector w. Then I get their cross product and I get that. So that's the idea. I need two vectors get their cross product. But yeah. Oh, I did get the same thing here. Because I just needed a point on any line. Yeah. And then here, coincidentally, I got all negatives. But this is fine. Mathematically, this is fine. Yeah, because at the end of the day, I got the same thing. Right? Did I get the same thing? Yeah, minus, 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 12, 3, 9. What I get here? 12, 3, 9. Yeah, I got the same thing. Could have been different, but no. Yeah. Okay, next. And I think this is the last. Oh, that was the last one. Oh, no. Lastly, I need to find the y-intercept of the plane. And so to find the y-intercept, when exactly does the plane intercept the y-axis, right? Well, it's the idea when y is equal to 0. So we just plug it in. Plus 3, 0 minus 4, plus 9, z minus 1. Oh no, actually I'm wrong. My bad. It's when x and z are equal to 0. I almost messed up the whole thing. Yeah, because this is only specifically in the y-intercept, right? So now I need to solve something for y here. Okay, so this is negative 36. 3y minus 12, minus 9. Okay, and I got 3y. I just add all of these to the other side. I get 57 here. 12, 9, 23. 12, 9, 36. I get 57. So 3y minus 57 is 0. 3y equals 57. Can I divide? Okay, so y is 19. So my y-intercept is 19. Or if I want to be specific, it's at the point 0, 19, 0. Doesn't really matter though, but yeah. Okay, let me see if I got that. And yeah, got it. Okay, I hope you guys enjoyed, and I'll see you all for part 4.